Inside your body, there is a transport network that most people rarely think about. It does not have the fame of the heart, the drama of the bloodstream, or the obvious movement of breathing. Yet every day, it quietly prevents your tissues from flooding, helps clean up cellular waste, and gives your immune system a way to detect trouble. This is the lymphatic system. It is sometimes called the lymphoid system, and it works alongside the circulatory system. But it is not simply a second bloodstream. It has a different structure, a different flow pattern, and a different purpose. Where blood carries oxygen and nutrients under pressure from the heart, lymphatic vessels collect fluid that has escaped into the spaces between cells. That fluid becomes lymph, and as it moves, it carries debris, proteins, bacteria, damaged cells, and immune cells through a network designed for both drainage and defense. To understand why the lymphatic system exists, start with the blood capillaries. These tiny vessels are where exchange happens. Nutrients, oxygen, and fluid leave the blood and enter the surrounding tissue spaces, allowing cells to receive what they need. This fluid outside the blood vessels is called interstitial fluid. It is not a mistake or a leak in the harmful sense. It is part of normal physiology. Cells cannot live sealed away from the bloodstream. They need a surrounding environment where materials can diffuse in and out. But once fluid enters those spaces, it cannot all remain there. If too much stayed behind, tissues would swell, pressure would rise, and normal exchange would become difficult. The lymphatic system solves this by collecting the excess interstitial fluid and giving it a route back toward the bloodstream. The numbers make the job surprisingly concrete. In an average day, capillary filtration processes around 20 liters of fluid from the blood. Most of that, about 17 liters, is reabsorbed directly back into blood vessels. But roughly 3 liters are left behind in the tissues. 3 liters may not sound dramatic when spread through the body, but if that amount accumulated day after day, the consequences would be severe. The lymphatic system acts as an accessory return route for this remainder. It collects the leftover fluid, now called lymph, and eventually delivers it back to the bloodstream. In that sense, the lymphatic system is not optional plumbing. It is a necessary balancing system, keeping fluid levels stable between the blood and the tissues. One major difference between the lymphatic and circulatory systems is that the circulatory system is closed, while the lymphatic system is open. Blood circulates in a sealed loop, heart, arteries, capillaries, veins, and back to the heart. Lymph begins differently. It forms from fluid already outside the blood vessels, in the spaces around cells. Small lymphatic vessels absorb this fluid, and from there it travels in one general direction toward larger lymphatic vessels and ducts. There is no central lymph pump equivalent to the human heart. Instead, lymph movement depends heavily on body motion, muscle contractions, pressure changes during breathing, and valves that help prevent backward flow. The system is quieter and lower pressure, but it is well suited to its task, collecting what has escaped, filtering it, and returning it. Lymph itself is similar in many ways to blood plasma, the liquid portion of blood. But because lymph comes from tissue spaces, it carries a record of what is happening there. It may contain proteins, waste products, cellular debris, damaged cells, and bacteria. That makes lymph more than just recovered fluid. It is also a moving sample of tissue conditions. As lymph travels, it passes through checkpoints where the immune system can inspect its contents. This is why the lymphatic system belongs not only to fluid balance, but also to immune defense. It connects distant tissues to immune organs, allowing signs of infection or damage to be detected and responded to more efficiently than if each tissue had to operate alone. The most familiar checkpoints are the lymph nodes. These small structures are positioned along lymphatic vessels, and they act like biological filters. As lymph passes through them, unwanted material such as bacteria, damaged cells, and debris can be trapped and examined. Lymph nodes contain high concentrations of lymphocytes, the white blood cells central to adaptive immune defense. When an infection is nearby, lymph nodes may swell because immune cells are multiplying and becoming active. That swelling is not just a symptom, it is a sign of work being done. The node is processing information from the tissue, bringing immune cells into contact with suspicious material, and helping coordinate a targeted response. Lymphocytes are the main immune cells associated with lymph, but their story begins before they enter lymphatic traffic. They are initially generated in the bone marrow, the tissue inside certain bones where blood and immune cells are produced. From there, different lymphocyte populations mature, circulate, and become activated in specific immune environments. Lymphoid organs provide those environments. Some are involved in lymphocyte production or maturation, while others are important for activation. The lymphatic system therefore links cell production, surveillance, and response. It is not merely a drain that happens to contain immune cells. It is an organized immune infrastructure, designed to move information and cells to places where decisions can be made. Several organs belong to this broader lymphoid system. The spleen filters blood rather than lymph, but it is deeply involved in immune surveillance and the handling of old or damaged blood cells. The thymus is especially important for T-cell development, helping prepare certain lymphocytes to recognize threats without attacking the body itself. The tonsils sit near the entrance to the throat, where they help monitor material entering through the mouth and nose. Together with lymph nodes, these organs show that the lymphatic system is distributed rather than centralized. Immune defense is not locked in one organ. It is spread across strategic locations where the body is likely to encounter pathogens or internal damage. Another important part of the system is lymphoid tissue associated with mucosal surfaces. Mucosas line areas such as the digestive, respiratory, and urogenital tracts. These surfaces are exposed to the outside world in a biological sense. Food, air, microbes, and foreign particles constantly meet these barriers. Mucosa-associated lymphoid tissue, often abbreviated as MALT, helps patrol these vulnerable interfaces. It allows immune cells to sample what is present near the surface and respond when necessary. This matters because many infections begin at mucosal entry points. By placing lymphoid tissue near those borders, the body does not wait for invaders to spread deeply before noticing them. After lymph has been collected and filtered, it eventually moves into larger vessels called lymph ducts. Two major drainage routes are especially important. The right lymphatic duct drains lymph from the right side of the upper body region. The larger left lymphatic duct, also known as the thoracic duct, drains a much larger portion, including much of the left side and lower body. These ducts empty into the subclavian veins, returning lymph to the bloodstream. This final step closes the loop in practical terms, even though the lymphatic system itself is open at its beginning. Fluid leaves the blood, supports the tissues, becomes lymph, gets filtered, and then re-enters circulation. Because humans do not have a central lymph heart, movement through this system depends on ordinary body mechanics. When skeletal muscles contract, they squeeze nearby lymphatic vessels. Valves inside those vessels help lymph move forward instead of slipping backward. Breathing also changes pressure in the chest and abdomen, assisting lymph flow toward the major ducts. This is one reason immobility can contribute to swelling. Without enough movement, lymph return may slow. In some vertebrates, specialized lymph hearts actively pump lymph into veins, but in humans the system relies more on distributed pressure and motion. It is a reminder that circulation is not only about the beating heart, body movement itself helps maintain internal balance. The lymphatic system was first described in the 17th century by Olaus Rudbeck and Thomas Bartholin, working independently. That historical detail is a reminder of how hidden this system is. Blood is visible when a vessel is cut. The heartbeat can be felt. Lungs rise and fall. But lymph moves quietly through delicate vessels, doing essential work in the background. Its name comes from the Latin word lympha, associated with fresh water, which is fitting. Like a hidden waterway, it drains, filters, and returns. Without it, tissues would become overloaded with fluid, immune surveillance would be weaker, and the body would lose a major pathway for cleanup and defense. So the lymphatic system is best understood as two systems working as one. First, it is a fluid recovery network, rescuing the liters of interstitial fluid that do not directly return to blood capillaries. Second, it is an immune intelligence network, carrying tissue information through lymph nodes and lymphoid organs where lymphocytes can detect and respond to threats. Its vessels, nodes, ducts, organs, and tissues create a body-wide infrastructure that supports both stability and protection. It may not announce itself with a pulse, but it is always active. Every day, it helps keep your internal environment clean, balanced, and defended, proving that some of the body's most important systems are the ones operating almost invisibly. If you found this helpful, please like this video and subscribe for more explainers.